So again, my name is Ira Thorpe, and I was a Ph.D. student down at UF for a couple of years. I graduated in 2006. I currently work at the Goddard Space Flight Center in Greenbelt, Maryland. And I think what you guys were all interested to hear is sort of what my career journey has been like, in particular, from UF to where I'm at now. And just sort of what my experience has been like and how it might be relevant for experiences you all will have in the future. So before doing that, I wanted to talk a little bit about kind of how I ended up at UF. Everyone's got their own kind of journey a little bit. Mine was somewhat unique from the academic perspective, so I think that's relevant to the experience I had both while I was at UF and also since then. And so I just want to go through that a little bit. So I grew up in Santa Fe, New Mexico. It's my favorite spot in the world. If you ever get a chance to go visit, you should go visit. And I was one of these people that yes, I often get asked the questions, and I think this was actually a question that was transmitted to me ahead of time. Like, did you know from when you were a little kid that you wanted to work at NASA? And I would say, maybe, probably not. I mean, I was interested in space, but like I was also interested in dinosaurs, and I didn't become a paleontologist. So, I think it was just sort of general, natural curiosity. And I was a good student, but I wasn't like a prodigy student or anything like that. Certainly had the kind of what we would call now STEM interests, although I don't think we called it that back in the 1980s. I went to college at Bucknell University in Lewisburg, Pennsylvania. And I actually started as a mechanical engineering major and actually finished as a mechanical engineering major. Took a bunch of physics courses there and sort of partway through my undergraduate career, realized my brain was more physics wired than engineering wired. But I decided from a practical perspective, it was good to have that engineering degree because I knew I could go get a job. And I ended up graduating with a dual mechanical engineering and physics degree from Bucknell. That basically was sort of a form of procrastination, right? Do two majors because you can't decide what major you want to do. And then I really couldn't procrastinate any longer. I had to, pick a graduate school to go to. I actually applied to engineering, applied physics, aerospace engineering, and physics programs, and got into a smattering of each of those, and ended up choosing the physics program at University of Maryland, College Park, in part because it was a really large school with a big, similar to UF, very big and diverse department. So I felt like I was keeping my options open. I always kind of have lots of interest, and it was hard for me to choose what to do. So when I applied there, it's physically located close to Goddard, which is where I'm at now. And at the time, they had a fellowship program for incoming graduate students where they covered your first year of teaching or research. Basically gave you your stipend, so you didn't have to teach during your first year when you're buckling down with all those courses. And then you came the summer after your first year and did a summer research program at Goddard. So I applied for that and was lucky enough to receive it, and came to Goddard, and that's where I discovered this LISA mission, which is really has been the kind of focal point of my career ever since, and probably for the entire career. So as part of that, working at Goddard, there was a Florida postdoc that was also working up at Goddard, and I ended up being paired with him. And we were working in the lab together, and I really got interested in this LISA mission, and I wanted to continue that as part of my graduate studies. And it happened that he had gotten hired as a new faculty down at Florida, and he said, "Well, why don't you come down and transfer from Maryland to Florida, and finish your PhD out with me, and you can keep working on this LISA mission." So I went ahead and did that. This is kind of why I wanted to call this out. So I did not come to UF as a fresh out of undergrad. I came to UF as a transfer student after finishing all my classes and my quals at Maryland. I actually took a master's degree from Maryland, again, sort of just in case. I want to make sure I had had some little check mark of something I completed. And again, a little bit different than what other students experienced was, because I was coming in having completed all my courses, and already with a research mentor identified, I just sort of immediately jumped into research when I got into UF. So now as a little segue, what is it about my research? Because I thought people wanted to hear about this too. It's something I like to talk about. So I work in gravitational waves, which if you don't know about them, you should. They're really exciting, and also you should because UF had a pretty major contribution to make in some of the theory and certainly in some of the experiments around this. And in particular, I'm an experimentalist, and so I like to introduce gravitational waves with this picture. Of course,
If you don't mind,
yeah,
or have you been switching slides this whole time? Because on your
I
screen, we're still on the title page.
interesting. So I think what I'll do is just stay in this slide sorter view. All right. So what I was going to show you that previously that's just a map of what I was talking about where I went.
Mm,
All right. So this is a slide I was on. You're seeing the gravitational wave slide now.
yeah.
Okay. So again, if you haven't, if you don't know about this, you should. And this is, what I consider sort of one of the most beautiful results this century in physics, which is the first direct measurement of a binary black hole merger by the LIGO instrument. So what you're seeing here is the actual wiggling of space-time coming from the merger of this pair of black holes. So this is kind of the core of the research that's really hooked me is to build a detector like this, but to build one in space. So here's a little bit about the LISA detector, and again, this is sort of just like an interstitial as to why I got so hooked into this thing. This is a more modern graphic picture, sort of saying what's going on. So what we do is we're going to build a constellation of 3 satellites. This is this cartoon here, and if a gravitational wave comes by, what it does is stretches and compresses space-time. This space-time that the constellation is sitting in, and it'll distort the constellation. So if you see this little graphic going by, it's kind of like a tidal distortion. It'll stretch the constellation and then return it to its normal or configuration, and then it'll stretch it in an orthogonal direction. And that plays over and over again, as the gravitational wave comes through the detector. The size of this thing is huge. It's about 2.5 million kilometers. On that little graphic there, actually the size of the sun is about right. You can fit the sun inside the detector. And we use laser beams to measure the distance between these satellites to the level of sort of tens of picometers, so sort of fraction of an atomic scale, in order to look for these gravitational waves, which are making that distortion that you're seeing there. So that's kind of the LISA concept. This is the modern picture of the concept, but the concept's been the same since the 1970s. If you're a gravitational wave person, you're saying, well, hey, you just showed me that we already had LIGO detections on the ground. Why do we need to build a space-based detector that's expensive and takes time? The answer is we need different kinds of detectors to go after different kinds of sources and at different wave bands, different frequencies. So this is a little bit like why we need to have radio telescopes and infrared telescopes and optical telescopes and X-ray telescopes and gamma ray telescopes. We can look at different parts of the universe and learn different things. That's kind of what this graphic is meant to show. On the bottom, there's a bunch of different sources. The middle is showing frequencies or time scales for these waves. And these space-based observatories like LISA, line up where their universe is producing a whole bunch of different kinds of, and also just a large number of signals. So there's a lot of science that we can do. So, I hope in those last couple slides, you saw how exciting LISA was, and it was a sufficiently exciting mission to, encourage me to transfer graduate schools. All right, so that finally brought me to UF, and what was my experience like there. So I actually managed to dig up this photo today. This was kind of fun. So this is Guido Mueller, who some of you may know. I know he's recently moved back to Germany, now a Max Planck director. But he was my advisor. He was also the postdoc that I mentioned. So it was sort of his last position before getting his faculty job, was up, was at Florida, but was working up at Goddard, and I was working with him as a new graduate student. So was this woman, Rachel Cruz. And so when he came down and started his new faculty job, he brought Rachel and I in as two students that had sort of already finished our classes and quals and could immediately start working in the lab. This is our lab that we worked in. I've actually forgotten the room number, but down on the first floor of or the middle floor of the physics building there, and physics building when I was there had that big giant live oak tree in front of it, which I understand has come down in a storm since then. So yeah, and this is me 20 years ago. And so what we were really doing in this lab is we were building up some hardware. I like to think of them as sort of a hardware analogy, but kind of proof of concept for this distance measurement between the spacecraft. We wanted to kind of be able to validate the basic measurement approach so that we could, sort of feed that back to the people at the agencies like NASA and ESA and some of the other European agencies that were really going to be building the hardware for LISA. At that time, LISA was supposed to launch in something like 2012 or so. And this is where I first really started working as a scientist and attending conferences and meeting the rest of the community and such. And eventually in 2006, I defended my thesis. It's got this really long title. But basically what I was doing was demonstrating one of the interferometric techniques using some of this apparatus you see in the photo. All right, so then now I'm getting finally into the part you asked me to talk about was what happened after graduate school. So, because we already had this connection to Goddard through both, my prior time there, but also because we were working to do research that supported a NASA mission, we had some contacts there. And one of the contacts was this gentleman, Jeff Livis, you see pictured there. And he sponsored me to apply for a NASA postdoctoral fellowship. So he didn't pay for it, but I had to work with him to help apply for this fellowship. And it was a mixture of LISA work, but also some intersatellite laser communications research. And so that was a 2-year position. I came in 2007 to do that work. And I really felt, even though I had been there briefly as a student, I really felt at home at a place like Goddard because it was a mix of engineers and scientists, and I had this engineering background and kind of that mixture of really practical, pragmatic building stuff with the more academic, interest in discovery, all in one place. That's a picture of the campus there. I really, really enjoyed it. So I was, very happy to be at Goddard and wanted to find a way to stay there. I started branching out to other parts of LISA, not just the interferometry, learning about other parts of the measurement, learning about some of the data analysis, some of the astrophysics, some of the mission design, kind of more engineering type stuff. And I got hired as a civil servant in 2009. So that means a federal employee. And that's, it's a permanent position. So that's sort of like landing a faculty job. Now, then things don't always go smoothly. So while we were still looking, by that time maybe we were looking like a 2015 launch. Space missions often go a little slower. In 2011, we had this really horrible event where effectively we were canceled due to funding shortages at NASA. And that's scary for me to say now because we're right now, focusing on or potentially facing funding shortages at NASA. So there's an actual, article from 2011 where this happened. It was really hard. There were, huge numbers of people on the team that had to be let go, and people I was working with every day all of a sudden were gone. It was quite challenging. But Europe was able to still, they were working on a technology demonstration mission. They had a separate mission called LISA Pathfinder that was supposed to be kind of a Pathfinder for LISA, and they were really supposed to happen, one and then the other. The Pathfinder was preserved and had a small NASA payload, and I was offered to basically move to be the lead NASA scientist on LISA Pathfinder. So I didn't have to physically move, but that my duties really focused on that. So that gave me, although the whole environment was pretty challenging at the time, it gave me something I could go work on and an opportunity to work on a flight mission. So, fast forward another couple years to the sort of 2015, 2016 timeframe, And we had it was really probably the best time of my career, when we had the LIGO detection. I don't know if those of you that know, it was detected in September of 2015, but they had to keep it secret for about 6 months while they were double checking and writing the papers and everything else. Although many of us were sort of hearing pretty substantial rumors that they had found something. And in the meantime, Lisa Pathfinder was launching. It launched in December of 2015, and the start of the real Lisa Pathfinder operations and the announcement of the LIGO detection happened 1 week apart. So within 1 week in February of 2016, we had the whole world all of a sudden knew what gravitational waves were. When I would go out and have social events with people, I didn't have to start explaining it. I could just say that thing you read in the New York Times or the thing you saw on TV or on Facebook or whatever. That's what I work on. And that was really fun. And of course, and it wasn't just cheering on the LIGO group. We had Lisa Pathfinder going. That was a lot of work. I spent a lot of time traveling back and forth to Europe, and a lot of sleepless nights of working on data coming down from the instrument. But it was really exciting at the same time. And as a result of those two things, LIGO happening and being very exciting, and then Lisa Pathfinder working really well. ESA restarted Lisa, but this time with ESA in the lead, the European Space Agency in the lead. But NASA was also, kind of renewed interest, saying, yeah, I think we want to get back into this. And one of the things that had happened is that the generation of people that had been the leaders when I came in as a student and a postdoc had all kind of, effectively aged out. They weren't going to be able to stay for a mission that was going to take another 10 or 15 years to launch. And so I had the opportunity to sort of become the new leader because I was at that middle career stage where I could see it through. So that's what I'm doing now. I'm the project scientist for Lisa for NASA. It's part of the leadership team for the project. That kind of means I don't do as much technical work as I used to do. I still try to do some. I would say a lot of communications work. So, and communications can be to general public. That's probably the most fun kind of communications work. But most of the communications work is sort of within the project, right? I need to make sure different parts of the project are talking to one another. That includes people in Europe and people in the U.S. and even within the U.S. within the NASA project. One of the things about a mission like this, it's very interdisciplinary. And so, what's going on with the laser system might affect what's going on with the spacecraft, might affect what's going on with the data analysis, might affect what's going on with the astrophysics. And my role as a project scientist is to kind of, have a really broad view as to everything that's going on and make sure nothing's slipping between the cracks. So it's a lot of opportunity, but also a lot of responsibility, right? You got this big team. This is actually just a fraction of it. This is from back in a review we had back this January. You see, I've moved from I'm in the middle here. I'm now wearing a sport coat and such. No more shorts and t-shirt, and a lot of people that are kind of relying on me to do my job. So then, just kind of looking forward, and I'll leave time for questions. What's going on with Lisa? Well, we are. This I borrowed this timeline from a presentation about a year ago and just moved that we are here. So we're in this, definition phase. But what this really means is, we've done a lot of laboratory tests. We've done a lot of technology development. And what that's allowed us to do is really get down to the nitty-gritty details of what our spacecraft and payload and instruments are going to look like, down to which resistor we're going to pick or which coating is going to be on, particular optic. And then we're at the point now where we're starting to transition into, either hiring companies or starting activities here at NASA and similarly, in Europe to actually build the final test units and then build the flight units for all the pieces. So, for example, ESA has just started the contract with their spacecraft contractor, which will, eventually result in the delivery of these 3 spacecraft. That will take us several years to deliver, develop and build and deliver and test all the payload, and then assemble it all into the spacecraft, and then launch sometime in the mid 2030s. We actually have a date, August 2035. Historically, it's hard to keep these dates, but we are going to do the best we can. And then a few years after that, we'd start collecting science and run for maybe another 10 years of doing science. So if you look at my career, I'm in mid-40s right now, so I'd sort of launch in the mid-50s and be able to retire around the time the mission ends. So, kind of if we hold on that schedule as a interesting twist of fate, what I thought was going to be something I would work on for my graduate career is going to end up being, the entire career. So that's, mainly just a quirk of when I happen to come on the project. But it also just sort of shows you how these big projects can really be, career length kind of efforts. So that's what I had prepared. I hope that was useful, and I'll keep the slides up, but also try to look at the cameras and see if people have questions. So hopefully that was useful.
All right, thank you. Does anyone in the audience have any questions? Yeah.
So why did you decide to go more to a project manager position rather than technical? Like, what are the pros and cons of that? Like, what do you like, do you enjoy, do you not like so much?
Yeah, and yeah, so there definitely are pros and cons. I think ultimately, the reason I, gravitated towards this leadership position is in part because as you could see by earlier, I ended up couldn't decide whether I wanted to do engineering or science. This allows me to kind of do the most or have visibility into the most amount of things on the project. So I'm kind of because I'm curious about all of it. I want to know about the astrophysics. I want to know about how the laser works. I want to know how you do the orbits. I want to know how you do the budget, right? And so having this project science position kind of allows me to go kind of explore all the different parts of the project. But the caveat is that I can't go very deep into any of those because I don't have the expertise. And one of the things that's just there's sort of different scales that you can do science, right? So you can do science in a sort of individual researcher kind of thing. You can do science in a small group on a tabletop, or you can do this kind of stuff, really big science where you've got thousands of people working. Um, you know, once you get beyond that one or two people, you really have to trust that the rest of the people are doing their jobs and are experts, because you can't double check them. You just don't have the expertise. You don't have the time, and so that's you have to be prepared to kind of give that trust to the rest of the team. But I enjoy it, and I enjoy the communications aspect of it. I enjoy talking to the management, talking to the engineers, and sort of being that being that glue that helps kind of connect different parts of the projects together.
All right. I suppose, or sorry, does that answer your question clearly?
Yeah.
All right, cool.
Yeah, I was curious, how was your transition from graduate school to going to work at NASA? Because you have a bunch of engineers and scientists, and the sort of environment you wouldn't find in graduate school.
Yeah, well, I mean, maybe just sort of the funny answer to that is, you finish graduate school, and you're thinking, now I'm going to be one of those postdocs. And at least I don't know what it's like at UF now, but the postdocs are kind of that next tier of seniority above the graduate students, and you're saying, finally, I'm going to be I'm moving up in the world. And then you get to NASA, and there are no graduate students or undergraduates, and the postdocs are at the bottom. And so it was sort of like, well, wait a second. I thought I was going to have a whole group of people I was in charge of, and now I'm at the bottom of the totem pole again. So there's that aspect. NASA is not, it's not an academic institution. It has, and then of course, NASA is a big and diverse organization, and the different parts of it have very different feel. Within science, we're sort of as close to you might have as an academic institution, but we're different. So there's no students around. You're not teaching classes, but there's a little bit of that kind of research thing. Of course, we're also a federal government, institution, and for the last 18 years, I've been a federal government employee. And then depending upon what's going on with the federal government, you have to react and respond to that. So.
All right, I actually have a similar question. regarding what happens when like groups lose budgets or when NASA starts having like funding shortages. I'm sure a lot of graduate students are interested in joining up on a project once they get out of here that may or may not have a somewhat shaky future in regards to having secure funding. So I'm wondering if you can share some advice or your experiences on how to weather the storm for when Lisa had that funding shortage.
Yeah, no, that's a good question. And so I'm gonna answer that in two parts. So one part is sort of funding aside, things like Lisa or any of these other sort of big science type projects, right? It doesn't necessarily have to be government funded big science, but things where you're in a large collaboration, it's going to take a long time. That could be working on fusion research or working on whatever it is. There is a danger to the graduate students, already working as a graduate student, but in particular the postdocs that come in to do this, because the postdoc ecosystem is designed that you're supposed to go in there, work for a couple of years, produce, and your job as a postdoc is to get your next postdoc or get a faculty job, right? I mean, that's your job for yourself, is to make sure you can advance to that next stage in your career. And in some of these things, like Lisa, where you're not going to have, unless you happen to be the person that joins at launch and then you're there for that first detection, okay, great, you can go get your faculty job on that. But if what you're trying to do is work your way up the ladder, but you're still 20 years from launch or 10 years from launch, you need to find and make sure that your postdoc is structured such that you can do something that is valued by the rest of the community, but in particular by your future, who you would like to be your future employer, so that you can keep moving on, right? And to kind of insulate yourself a little bit against, schedule slips or those kind of things. So that's certainly, when you're looking at your next move out of grad school, you should be sort of playing chess and thinking, well, what's my move after that? And not just worrying about like, oh, great, I got the job I wanted. It's going to be fun to work at NASA. It absolutely will be. But what you don't want is, it was fun to work at NASA for 3 years and I didn't publish any papers because I was, working on an engineering type thing or this other kind of interesting problem, but I got no papers published and now I can't get my next job. So, that's certainly something you need to be aware of, regardless of where you're working. And it can be exacerbated when you have these, these really long kinds of missions, where there's, not that direct return on science. I mean, I'm an experimental scientist by trade, and so that happens to us sort of, naturally a lot. That we tend to write fewer papers because it takes more time to build a test and use the apparatus. You can't just sort of come up with an idea and work on it for a little bit and publish a paper in 6 months. It just doesn't happen. So when a postdoc is 2 or 3 years, you got to be really careful about planning that. Does that answer the question?
Yeah, somewhat. It answers it in an interesting way. Thank you.
Yeah.
All right. I think that's all of the questions, unless someone else has one in the back of their mind. All right. Once more, I'd just like to thank you for actually showing up and giving this talk today. It's been really interesting.
Well, I'm glad I actually showed up. Yeah. Sorry about the AV issues. And it would be great to go down and visit Gainesville again, but just too much going on. So we'll see.
No, I get it entirely. It gets busy.
It gets very busy.
All right. And unless anyone else has any further comments, I think we can start wrapping it up here.
All right. I will say, if people have questions, they wanted to get in touch with me directly, you're welcome to distribute my email address to the group, and I can answer people's questions. I can't promise I'm going to get to every question like immediately, but if people say, hey, I have a particular question, just let me know and I'll try to answer them.
Yeah, I'll be sure to